Good afternoon and welcome to our webinar. Today we'll be talking about how to reduce the high cost of archiving business documents. My name is Michael Solarczyk and I'm the Business Development Manager for Ecodocx. And joining me today is our Technical Architect, David Shee. I want to thank you all for taking the time to be with us today. This webinar will be approximately 30 minutes, and during the webinar you will be muted to avoid any background noises. If you have any questions during the webinar, please use the chat section and we'll answer your questions towards the end. So now if you're ready to start, let's jump into it. The scope of today's webinar is the growth of documents that we need to archive and store, strategies that companies are using to reduce archive storage growth, actual case study done on a company based in Spain, and the results from using the Document Archive Optimizer. New strategy to optimize PDFs to significantly reduce storage requirements, business benefits. Towards the end, we'll allow some time for questions and answers, and then we'll close the session with a short summary and follow-up. As your digital documents transform from basic black and white text to more vibrant, colorful designs, your storage needs will increase. The growth of storage is typically driven by an increase in customers, so more customers equals more documents to produce and store. Compliance and regulatory laws play another role in increasing your costs. Long-term archiving and retention requirements that vary by state can have significant impact on your storage costs. Another increase in costs are more complex business documents. For example, branding, such as logos, color-themed invoices, and more customer-friendly documents such as graphs, pictures, or trans promos. And lastly, outsourcing and cloud storage can change your cost from $5 per gigabyte in-house to about $10 to $15 per gigabyte when it's outsourced. Now that we have touched on how the cost of your digital transformation increase, let's talk more on what happens when your documents do evolve into more customer-friendly communication tools. As shown in this example, from left to right, with each transformation, these documents get more vibrant and much larger in size, which requires more storage, which equals to more cost and longer storage and retrieval times. With each change, your company requires more storage, which requires more equipment, which costs more money. If you own your storage facility, you have already invested and continue to invest money into hardware, maintenance, support, and replacement. But if you're outsourcing, you pay extra for CPU and network usage. As we all know, the storage requirements grow as the number of your customers, document complexity, and retention periods increases. As you can see on the graph, the red line represents the disk storage needs to accommodate the number of documents that needs to be stored. Over time, this can be very costly. The solution to this ongoing dilemma is Archive Optimizer, that reduces the size of archive business documents by up to 97%, which will cut your cost of storage by over 90%. Now, let's talk about reducing storage growth at the business document level. As the storage needs grow, we turn to any possible solution to help cut costs, without always thinking about regulatory standpoint or time spent on regenerating documents. Here are several ways companies reduce the growth of storage related to archiving outbound customer-facing business documents. First, postpone or limit scope of digital transformation initiatives. Companies will not invest into transformers, advertisements, or more vibrant documents. They'll rather make the documents plain and simple. If they choose to do any type of advertisements, they will do so by inserts that come together in an envelope with a document, and 90% of the time, they end up in trash unread with that envelope. By doing so, these companies lose their chance to advertise new products, services, or solutions. And if they're in competitive industry, they lack the exposure to their customers. Selective archiving is another way to reduce storage needs. Companies will archive what's only absolutely necessary. With that, these companies run into problems that customer service agents are not able to see the details that the customers may see on their invoices or statements. In this case, the system needs to generate two separate documents, one that is archived and one that the customer sees, which creates a disconnect between the customer and company's representative. Another method is archiving only raw data or regenerating from source. Companies require real-time reprocessing, which would not guarantee identical content or layout. And unfortunately, if you are in the regulated state or industry, this method does not follow your compliance guidelines. On a side note, if you're required to use PDFA files, None of these solutions work for you, as your documents must be in unchanged state from the moment of distribution, archiving, to retrieval. Now, let's talk about reducing storage growth at the system level. Compressing archives is when your archiving system zips documents before storage. This method works great on a plain text with an outcome of about 80% and between 20 to 60% on the rich content documents. Data deduplication is another method that enterprises are using. Companies like Quantum or EMC are pushing this solution because what data deduplication does, it works on a file level and sifts through the data and stores only one copy of a duplicate file. Then it creates a link to all other duplicates after the storage. Unfortunately, this doesn't work for most outbound customer-facing business documents, as they're all different. Another one is PDF optimization of business documents, which requires knowledge of PDF file instructions and streams. PDFs have resources built into them such as logos, embedded fonts, objects like transpromos, and interactive content, which are extremely large in size. The optimization ratio improves with the number of graphics, logos, transpromos ads, and interactive content. During the outcome process, the documents are identical before and after optimization. Now that we have talked about the costs and solutions, let's dive into Archive Optimizer case study. The images on the screen are the actual residential gas bills from the company in Spain. As you can see, the first page on the left includes summary and details of the bill, and the second page to the right includes all promotional and advertising messages. Before we move forward, I'd like you to focus on these documents. We already know that as the customer base and number of documents rises, so does the needs for the storage. The upside of evolving your documents to be more vibrant and customer friendly, it allows you to turn an empty space on your documents to a prime advertising spot that each customer will see, which your marketing folks will love. Also, more user-friendly and easy-to-read documents should receive faster payments, as the customers will limit their number of calls to ask questions. Now, keep in mind that individual results will vary based on the state and different requirements in terms of retention and regulatory compliance. Here are the company's actual numbers that Archive Optimizer was working with. We aren't talking about 9% optimization. We are talking about an average of 91%. If you do a simple math, 91% times 5 years equals to 8.7 million euros, which is almost 9.5 million US dollars. Those are a huge savings. And the best part is that the company saw their ROI within 3 months of implementing Archive Optimizer. Now, I would like to turn over to David Shi so he can explain how the optimization works.
Okay, so I'd like to talk a little bit about how PDF optimizing works. The core concept is quite similar to data deduplication, but instead of identifying commonly used files or blocks on the disk, it revolves around identifying commonly used resources in your outbound business documents. And just storing them once. Logos, embedded fonts, trans-promo messages, for example. So optimizing the PDF requires some understanding of the structure of PDF files. So PDFs embed binary objects as streams. A PDF stream can be a GIF or a TIFF image, even a flash movie, digital certificate, digital signature, in interactive form, or embedded fonts. Embedded fonts are pretty significant. If your PDFs have to comply with PDFA standard for long-term archiving, they're required to include embedded fonts. So embedded fonts can be the entire font. It can be a partial subset of the font. Either way, storing that same font set 1,000 times or 1,000,000 times in your archive quickly adds up. So quite often we find that embedded fonts take up even more space than logos and other images. The first step in PDF optimization is to identify those PDF streams. So PDF streams are like MIME attachments in an email. The MIME attachment, the MIME metadata allows us to identify the type of binary object. So if it's an embedded font, an image, a flash object, or an interactive form, we can extract that from the original PDF and store that once in the Archive Optimizer repository. Frequently used PDF streams are stored once as separate objects instead of being stored 1,000 or 1,000,000 times as embedded objects in the PDF files. So what's left of the PDF file is a greatly simplified, basically a text file is all that's left, with all the unique metadata, plus anything that's unique to that document, like a digital certificate or a signature. It's much, much smaller, much less complex, faster to store in your existing archiving system, faster to retrieve. And then when it comes time to retrieve the PDF from archive, the process works in reverse. The stripped down PDF text with all its unique document data is pulled from your existing archiving system. The commonly used PDF resources are attached to it, and then the Archive Optimizer returns the original PDF file. So the PDF file that comes back is identical at a binary level to the PDF file that was stored. So if you wanted to, you can print out the before and after, hold them up to a window to compare. If that makes you happy, it's kind of a waste because you could just use a binary diff tool to compare the files, and they are exactly the same before and after, including the digital signatures and the certificates. PDF optimization is a generic add-on to your existing archiving or content management system. So whether it's a homegrown archiving system or something like IBM FileNet, OpenText Archive Server, OpenText Content Server, Documentum, whatever, it should work. We've done integrations with a number of homegrown file system-based archives, but we've also solved the hard problem, which most people would consider the hard problem of integrating with SAP ADA, the SAP archive link to OpenText Archive Server, also known as SAP Archiving into Document Access by OpenText. So the integration we've already done, it's a really, really slick solution, and if you use SAP ADA or SAP Archive Link, we can actually talk later and go through some more of the details about it. Archive Optimizer is a Java app, so it's been integrated into J2EE servlet containers, so you can access it through web services or through your website, your customer portal. It can be called by SAP Archive Link. It can be called by other Java classes. It can be called from a command line, a Perl script, pretty much whatever. It works with your existing document composition center system, whether that's something like StreamServe, HP Extreme, Doc Origin, Jet Forms, Adobe Forms, SAP Forms, Oracle Forms, whatever. It'll work with those existing systems. And I guess turning to the little chart, long-term storage is directly proportional to your cost. The slope of your cost graph will vary depending on the size and complexity of your documents and the price per gigabyte storage costs, whether it's local or hosted in the cloud. But either way, by reducing the size of the archived PDFs by over 90%, up to 97%, PDF optimization can significantly reduce your overall cost of storage. For the business user that's been putting off document transformation initiatives due to pushback from IT or budgeting over storage costs, Archive Optimizer now allows you to go ahead with rich content and interactive forms. We actually find that documents with more rich content have a higher optimization ratio. So Transpromo actually works to your advantage.
All right. Thank you, David. And at this point, we want to turn to your questions. So if you have any questions, please feel free to ask. You can unmute yourself and then ask questions, and we'll be more than happy to answer them for you. Again, if you have something more detailed, we'll be more than happy to take this offline and talk to you separately. But if you have any questions that maybe you want to share with everybody, because they might have the same questions as you are, we'll be happy to answer them right now. So,
yeah, this is Steve Mandel. Hey, David, I joined late. How much did you say the solution reduces the PDFs by what percentage? PDF type?
Up to 97%. So typically around 91%. So here's a list in the upper right corner. You see a table with a list of the customer's various document types, and so they sent a couple thousand documents of each of these types. So some of them compress better than others. Some of them are in the high 80s. A few of them are in the high 90s, but on average, it's around 90%.
Great. Thank you.
This is George Tomkeys. I have a question for David at a very high level.
Sure.
I heard you mention StreamServe earlier, how this works with this. Currently, we're producing our PDFs. With the project, would we have to do some type of modification with our project to include this optimizer? I don't want to really get into too much detail, but could you explain to me at a high level how that would work?
So currently, I think your PDF archiving from StreamServe writes the PDFs and the metadata out to a file system, and then you ingest the metadata and you store the PDFs to separate directories in the file system. So what we would do is we would have the archive optimizer sitting kind of as a proxy. So it would pick up the PDFs and compress them, and your existing database would continue to hold the metadata. So at a storage level, so at a StreamServe level, we'd still be writing to a file system, or we could call a Java app to archive it and compress it immediately. Most likely, we'd just continue writing to a directory. It might be a slightly different directory. The metadata would be exactly the same. The only difference you'd notice is that your file system storage would be a lot smaller. When you go to retrieve the documents from your web portal would call a Java class, which would reassemble those PDFs back to their original state. So the StreamServe changes would be negligible.
Okay. We stored these PDFs in a file directory, over in DB2, to where if a customer calls in and the CSR has to pull up that PDF, all of the stuff behind the scenes, is it real time? I mean, how fast does it take to assemble that and pull it back up so the CSR can view it?
Wow, great question. Okay, so the CSR wouldn't be able to pull it up from the file system. They'd need to use the archive optimizer, like app or whatever. So it is real time. So in our testing, it can be real time. It can be batch. So we do find. It adds maybe a second, maybe two, to it. What we found with, database based archiving systems is that because we are storing a much simpler PDF that's stripped of the logos and things like that, the attachment that's stored in the database is much smaller, and so even with the processing time of us identifying these PDF streams and pulling them out, it's actually faster because we find that the object stored in the database is so much smaller.
Okay.
So that's my long-winded way of saying your mileage will vary, but it's typically comparable, and it may even be faster.
Okay. All right, thank you.
That was a great question. Hope I answered it sufficiently.
Yes, you did.
Okay. Any other questions?
Yeah, excellent presentation, and we are interested in the archive optimizer.
Okay, great. Thanks a lot, Steve. Okay.
So again, thank you. We had some great questions. If you think of any more questions and you want to take it offline, please feel free to send them to us. After this session, I will send you an email with my information and the link to the webinar, just because we were recording it, so you can share it with whoever you think might be interested in it. And but until then, stay tuned for more educational webinars from Ecodocx. And thank you again for joining us today. And have a wonderful rest of your day.
All right, thank you.
Thank you.
Thank you. You too.
Hey, guys.